Hello all, we are learning a state flow. In the state flow, we have finished the introduction to state flow where we learn Simulink and state flow are a powerful combination and the system needs to respond to both continuous and discrete changes where the Simulink models give us a continuous response and changes, and state flow will give us a discrete changes. So that's why we require a combination of both Simulink and state flow to get a good output from the code or like whatever we're doing in that way. Okay. And we have done with a flow chart, flow graphs, and all this thing, how we can create that. And we have created this example Coke dispenser using this and all this thing. Now we will start with the chart. So basically, I just want to introduce that this is the chart, but here inside I will be having a model. Okay, here also I will be having a model. So this is my main chart, yellow part, what you are able to see here. If I want to add this chart, I already told you I can search here in the chart and I'll get this chart here. Or else I'll take it from a library, Stateflow. From there also I'll take one chart. That chart indicates it's a state flow. Inside it, we will not design a logic. We will like flow, or we can like like state flow way we can design the chart. But all the state flow will be happen in a chart only. Okay. So what is the state chart and all these questions for you? So then I'll answer that simply. The state chart is an essential part of a state flow that offers a visual tool-based environment for a finite state-based development. A state chart can be described as a graphical representation of the finite state machine, consisting of graphical objects, non-graphical objects, and their relationships. So it's consisting of the graphical objects, non-graphical objects, and their relationships as well. So states represent a possible operating modes of a dynamic system. So in this session, we will explore state chart and its various characteristics with simple examples. So in this session, we will learn about the state transition diagram, state level, that hierarchy, decomposition, and all type of transition possible in a state chart. And also we will learn like introduction part of the junctions and state grouping techniques and all this thing. So main points you will learn here, like a state label, how that state label, state name, state action will work, how the state hierarchy will work, the transition, state transition, default transition, self-loop transition, remote transition. There are various ways of transition. Decomposition is also there. Or decomposition means exclusive, or and decomposition from parallel. And junction, we will learn that history junction, connection junction. There are two types of junction we have to learn in this session. Okay, and that group and charts, that also we will learn here. So the basic overview, if we want to know, as we have already learned about in a previous sessions, the state flow provides a visual tool environment based on a finite state machine. A state machine, also known as a finite state machine, represents a reactive system that works in event-based manner, which indicates that a dynamic system's operating mode states change only on occurrence of the defined events under a certain conditions. Stateflow uses state machine like schematics presented by some David Harrell. He is a developer for the Stateflow who was told us to use the Stateflow assuming that thing, along with the control system and state machines, are used to implement complex logic in dynamic systems such as automation, automotive, aviation, industrial, telecommunication, commercial, and so on. So in the state flow, that's all about the state flow. Now we will know more about the chart. So a chart is in a state flow is the visual representation of a finite state machine that consists of graphical objects such as transitions, junctions, and states. Non-graphical objects such as event and data that the relationship between them. The chart offers various options to implement combinational and sequential logics, such as flow graph, state transition diagram, state transition table, and truth table. So in this session, we shall learn the techniques to describe the event-driven system with the help of state transition diagram. So we have did that state transition diagram previously also with the flowchart also is one of the kind of state transition diagram that is the constructed with a two elementary building blocks. One is state and another one is transition. So here we will learn about the states and transition. So what is the state and all this thing? This question will be for you. So in a chart, if I open, so this thing is known. You can see one yellow box is coming there. This thing is known as a states. States. Okay. So in this session, we will learn about that the state transition diagram that constructed with a two elementary blocks that known as states and transitions. So in a case of complex system, state transition diagram are insufficient. In this case, the state chart combines the uses of hierarchy, parallelism, and broadcasting for a complex algorithm such as systems. So Stateflow offers a choice as a chart action language, Matlab and C. In Stateflow, a chart can be built as a standalone chart that is executed as a Matlab object. The state chart files shall be created with the .sfx extension. It is .sfx extension. Okay. Additionally, the chart can be created as a Simulink block to be simulated as a part of a Simulink model having a .slx. That also fine. That's also one of the things we can do .slx. Okay, or .mdl if we have a file extension previous versions. Okay, the state flow the state flow chart works as a finite state machine in a Simulink. The state flow chart block is also simulated along side other Simulink blocks present in a model during simulation. Simulink generates S function in the case of hybrid system. Another existing aspects of hybrid system is that it is also possible to use a Simulink and MATLAB function as part of state chart. A chart in evoked cyclically on the event or based upon a chart input. So there are various ways. So now I have told you this is the state, and now we can drag and drop this state and all these things. Okay. So what is the state and all this thing will be questions for you, and that example which I have switch on off light will be on off, that is the state transition diagram, one of the example which I have implemented in front of you. I'll explain that before I'll explain the state also. Okay, so a state in a state flow chart is used to describe a different operating modes or reactive system. The state is a fundamental building block of the state transition diagram used to describe a sequential logic. A visual characteristics of a state is that a state can be either active or inactive at a given point in time. The state can be active or not shall be decided based on events and conditions applicable to the specific state. The control shall move dynamically from one state to another state accordingly. So we shall follow the steps to create the state, how we can create the state and all this thing. So in that way you can see I have taken a state from here. Okay. Or I'll double click here, I'll search here, just create a state from here, so I'll get the state. So these options are available. Okay. If I am not here, if I am coming here, if I am double click here on the state, you can see first the name is coming there. In that way, you can open the state. So in a state, we are having various ways to do something. So we have to write some name. Suppose here I have written a off. So I'll write in front of you, this is my off state. Okay. So we have the things we have to know, rename the state, how we can rename the state. Okay, we have created a state. So if I want one more state, okay, with some name of on, okay, I'll take one more state, name is an on. Okay, so there I have created two states. Now, what is a create a transition? To create a transition from one state to another state, I'll come at the end to the state and I'll create in that way a transition from these two states. So we have already studied that in a flow chart, the transition and all this thing. Okay. So here also we will get the three options. That one is for event name and message name. Another one is like for condition in a square bracket and action in a curly braces. So same thing I have written here. This is my condition in a curly in a square brackets. If the condition will satisfy, it is jumping to here. Okay. So that update the label of the state, we can update this name in that way, label and all this thing. So transition condition also we can update in a flow graph. There are so many things defining a data. Here you can see I have defined the data. We already covered that part. How can we define a data in model explorer? How we can define a data which we want to input and what we want. So here all and off are my constant. So I have it's here. You can see it's CC. It's coming here, and switch input is my input, and lab out is my output. Okay. So if you want to know more about this example, I'll explain you in detail. Before that, I want to explain few more thing about the state. So state is having the things we need to know about the state label. The name is known as a state label. Or like a state label can be termed in a text of a written top of the cover of the state by the default that state like what we are giving a name to the state that should become here at the top. Okay, this label should be known as a state label. Okay, that top label. That state name is known as this name where we have written on and off. Okay. And after that, we have the three types of action, state action. One is entry, another one is during, and last one is exit. So state actions are various types of actions performed in an active state, which are optional. We can either skip them or specify of some of also we can specify here in a top model where I have used only entry. Okay, there are various ways to write these state actions as well. So we can either skip them or specify some or all of them based on our requirement. To describe more about the state action, we can predefine a keyword and prefix. That that prefix are known as like if I'm writing a em. Okay, that also known as an entry. Or if I'm writing complete word entry, entry, and I have to use this colon here, colon, to write some condition in my entry. And next one is during. I have to use small only everything. DURING during. I'll use a colon. Okay. Now I'll press a enter. The last one is EXIT exit. So these three state actions are there. We will learn about that every action now. I'll describe the every action and I'll show you here we have few more ways to write the same thing. EN for entry. Okay. DU for during. We can use this short form. EX for exit. These three ways also we can use to write any state. Okay. These three ways. Instead of writing complete, you can write EN, DU or EX also. So on event name, like on some we want like something we want to do with that also we can do. Okay. So now I'll explain you what happened in an entry. So entry, we can write entry or EM for that. The keyword is that EM is used to specify an action executed once a state becomes active. If no keyword is specified, then the state action is considered as an entry action by default. Another alternative to the prefix is forward slash that we can do in a forward slash. To specify the multiple entry action, we can write them to separate rows and separate them using comma or colon, as it can be observed in a previous example, like how we are doing here. We can observe here in this lamp example what we have, uh, a lamp on and off state actions that perform based on the switch status. The output values is held until the entry action of the subsequent state is executed. Okay, that will be happening here. We will see the example. This example also we will learn. Okay, just I'm explaining before that. I'm going to start explaining the example. This all the concept of that state, how we can do all this thing. Okay, so another one is a during. During or du keyword describes a state action that gets executed for an active state whenever an event occurred or no exit condition is true. We can separate multiple during actions with comma, semicolon, or courage written similar to entry action. One use case during the action is incrementing the timer or a counter on each time step occurrence in a specified event. Okay, so another one is like exit. So exit as a name suggest exit or exit ex, like ex idea exit or ex we can read action performed just before the exit said active state. When a transition out of the state becomes a valid. The syntax of exit action is similar to the entry during actions. The mode to separate multiple actions is also the same. Like suppose the state has a condition action on outwards transition along with an exit condition defined for the state. So in that case, the first condition action is executed. When the condition is valid, then exit action of the first state is executed. After execution of the action, first state becomes inactive, and then transition to the second state keeps place, where the entry action performed once the second state becomes active. So in that way, entry during exit for the each states will be working in a flow. Suppose it is transition from here to here, in that way it will work. So that's it.